All right, today we are in Polynomials lesson 2. We are multiplying polynomials today. And there's a process for multiplying polynomials, and it's called the FOIL method. I want you to kind of circle those first letters in each one of the terms, all right? And it spells out the word FOIL. FOIL is the method that I use when I'm multiplying binomials. We know that binomials are polynomials that have two terms in them. All right? So FOIL, all right, this graphic kind of shows us how it works. The very first thing I do is I multiply my first terms in each binomial together. And x times x is x squared. Well, how do you know that? Well, that's because if there's nothing there, there's an understood one exponent with each of those x's. So I just kind of wrote that in. And I know based on my rules of exponents, if I have the same base, I can add my exponents together. And 1 plus 1 is 2. That's why x times x is x squared. You're going to see a couple examples today, really capitalizing on that, on your product of powers property, where you can add the exponents when you have the same base. All right? So multiply your first terms, then multiply your outside terms. So here we have x times 2 equals 2x. Then you multiply your inside terms. 1 times x equals 1x, or just x. Then you will multiply your last terms together. 1 times 2 equals 2. Then the last step would be to combine all of our like terms. So that's what we're going to do in example 1. Example 1 really is the heart or the meat of what you need to learn today. All right. In Algebra 1, you're going to learn the same FOIL method again. So you should be familiar with it by the time you get to that concept in Algebra 1 next year. All right, so the FOIL method, again, starts with the first term in the expression. So we do x times x. And remember, guys, when I do x times x, that means I need to add the exponents. So what is x times x? What's x times x? X squared. Okay, now let's multiply the outside terms. What's x times negative 4? The outside terms, x times negative 4 is what, guys? Negative 4x. I multiply my number and my variable together to make negative 4x. Now I multiply my inside terms. What's 2 times x? 2x. Positive or negative, guys? It's positive because both of those terms are positive. Then I multiply my last terms together. What is 2 times negative 4? Negative 8. Okay, but I'm not done yet because now I need to look back over all these simplified terms and see, is there any like terms that I can combine? Are there any like terms here? See you guys kind of nodding. What like terms do you see? The 2x and the negative 4x. Now, x squared is not a like term because the exponents have to be the same also. You paying attention? Look up here. Look up here. Okay? So x squared just gets brought down. I just bring down x squared. And what's negative 4 plus 2? Negative 2, and then bring down your common variable, x, minus 8. X squared minus 2x minus 8. All right. Okay, now I want you to do the z problem. Okay, I want you to do the z's on your own. Go ahead and do that one. It's the same thing that we just did. Austin, what'd you get when you multiplied your first terms together? Z times z. Z to the power of 2. Ayana, what did you get when you multiplied your outside terms together? Z times 6. What's z times 6? All right, anybody want to? Yeah, very good. Just 6z. You just multiply the number and the variable together. 6z. All right, Reagan, what about your inside terms? What'd you get when you multiplied? Very good. And Micah, what'd you get when you multiplied your last terms together? Negative 12. Very good. Now, guys, is this my final answer? Am I done now? All right, what like terms do you see here that we can combine? 6z and negative 2z to make what? Positive 4z minus 12. Anybody get that right? Anybody maybe just miss one part of that? Just one little... Okay, so let's make those corrections. All right, now let's look at the r problem when I'm multiplying my r's. Now what I see when I multiply the first term is I see I have a coefficient now, a coefficient of 2. Well, I also have a coefficient in front of the first term too. Even though there's nothing there, what number is understood in front of a variable? It's a 1. So technically what you're doing is you're just multiplying your coefficients. What's 1 times 2? It's 2. And now you're going to do r times r just like the others. And when you're multiplying the same base of r, what do you do with your exponents? You add them together. So r times r, r is r squared. Does everybody see how we got 2r squared? Just multiply the number, and then your variables, you would add the powers. Now I do my outside terms. What's r times negative 1? Negative 1r. What's negative 5 times 2r? Negative 10r, right? Negative 5 times positive 2 is negative 10. What's negative 5 times negative 1? Is it positive 5 or negative 5? It's positive 5. Okay? Even number of negatives is a positive answer. I multiplied 2 negatives. Is my answer done now, though? Is this my final answer, guys? All right, you're shaking your head no? So let's read our final answer together. 2r squared minus 11r plus 5. Now, I got negative 11r because this was same sign, add and keep. They're both negative. All right, what do we notice that's different about our ends? The ends. What do you notice that's different here? What do you see with your n in the second term? You already see a power of 2. But you understand that this means n times n squared, which means that you would add your exponents together. So now instead of the other ones, when it was just 1 plus 1 equals 2, now it's 1 plus 2 equals what? 3. So now you would get n to the third power when you multiply your first terms together. Okay? So you see, guys, when you're multiplying variables, you're adding your exponents. Okay? What happens when you multiply the outside terms now? What's n times 3? 3n. What about your inside terms? What's 2 times n squared? 2n squared. And then your last terms, be careful. What is 2 times 3? 6. Do not add them. They are positive numbers being multiplied together. Number one mistake I see is people will say 5. But you're multiplying these numbers, guys. 2 times 3 is positive 6. All right? Now, do I have like terms to combine together? Look at them. Look at all your n's. Do you have any variables that also have the exact same exponent? No, you don't. You have all different exponents, which means that nothing can be combined. However, this answer is not in its final format. Can anybody tell me why? William? Yes, it's supposed to go descending in order. So which one comes first? N to the third power plus what? 2n to the second power plus 3n plus 6. So on your final exam or on your quiz on Wednesday, if I were to give you the option of these two answers, would you pick the correct answer in descending order? Okay, so standard form, if I said, choose the polynomial that is written in standard form, could you do it? Could you pick the descending order, okay, to represent standard form? All right, now on the next example, I'm multiplying a binomial, meaning it has 2 terms, times a trinomial that has 3 terms. So what happens here is that I need to distribute the terms in the binomial. So this is what it looks like, guys. I take the very first term in my binomial, and I'm going to multiply it by each term inside the trinomial. I'm going to distribute that term. Now, remember what we said about our exponents. What would be x times x squared? My first term's being multiplied. What's x times x squared, guys? X to the third power. Now let's go to my next one. What's x times 5x? I'm distributing here, guys. What's x times 5x? Add your powers. 5x squared. 5x squared. Okay? Now, what's x times 8? 8x. Okay? So now I'm done distributing the first term. Now I must distribute my second term into the trinomial. I got to multiply that now. Okay? So what is 1 times x squared? 1x squared. What is 1 times 5x? Nope. Just 5x. And what is 1 times 8? 8. Not a trick question, guys. 1 times 8 is 8. Is this my final answer? No. What do I need to do now to get my final answer? I need to combine all my like terms. So I start with the very first one. Is there any like term with x to the third power? So bring it down. Okay. Is there any like term with 5x squared? What is it? 1x squared. So 5 plus 1 is 6. And bring down your common term, 6x squared. What about 8x? Is there anything like 8x to combine? What? 8x plus 5x is 13x. Is there anything left? Just 8. Nothing to combine there. So that's my final answer. Is this answer written in standard form? Yes. Yes, it is. So I don't need to rearrange anything. It's descending with my number coming last, my constant. Okay? All right. I want you to try the next one. Okay? We'll just pause here for a minute. I want you to try to solve the next one. The next one has negatives, so just be careful of your signs. All right, Kaylee, what'd you get when you multiplied your first term together? N times n squared. N to the third power. Did you guys get n to the third power? Did y'all get it when you multiplied? Okay. Sabrina, what'd you get when you multiplied your second terms? Very good. Negative 2n squared, because I add my powers of n. All right. Anais, what'd you get when you multiplied your third term?
4n.
4n. Very good. All right, Brody, what'd you get when you multiplied your second term in the binomial times n squared? What's negative 3 times n squared? Now you have to go back and you have to start multiplying the second term. What's
-3n squared.
Yeah, very good. Negative 3n squared. All right. Marcus, what did you get when you multiplied the next one? Negative 3 times negative 2n. What would that one be? Okay, but what would it be? What's negative 3 times negative 2n? Okay, close. All right, but we're not adding. We need to multiply, William.
6n.
Yes, positive 6n. Did you put a plus sign in front of 6n, guys? Did you put a plus sign? Because when you multiply a negative times a negative, your result is a positive. That's why it's plus 6n. All right, now, y'all tell me what's negative 3 times positive 4. That's the way I want you to read this. All right, heads up. Let's go. Heads up. All right, is negative 12. Now, I'm not done yet. Is there any like term with n to the third power? Anything like it? Nope, bring it down. Austin, what about my negative 2n squared? Is there anything to combine with it? Very good. And what'd you get? Negative 5n squared. Perfect. Reagan, did you combine anything with 4n?
Yes.
Perfect. What did you get? Very good. Positive 10n. All right. And then anything to combine, guys, with negative 12? Nope. Just bring it down. Okay. Did you get it right? Anybody get it? Okay. So we're just working on a lot of different concepts here, guys, are getting brought into the picture. Combining like terms. Adding and subtracting my positive and negatives. Have y'all been racking your brains for those rules? Remember, the same sign, add and keep. Okay, different sign, subtract. And then even you're multiplying positives and negatives. It's a lot of concepts coming together. All right, last example deals with a football field. Okay, so a lot of you guys can relate to football field. Either we go to football games, we watch football games, or we play in football games. Football field, here we go. Write a polynomial that represents the area of the football field. Well, we're kind of dead in the water if we don't know how to find the area of this kind of shape. What shape do we see here? It's a rectangle. How do we find the area of a rectangle? How do we find the area? What's my formula? It's length times width. Length times width, guys. Write it down. Circle it. Highlight it. Okay? If we don't practice these concepts, we lose them, which you might have just been reminded of that fact. Okay? Area of a rectangle is nothing new. It's length times width. Well, what is the length of this football field? 10x plus 10. Looks a little weird, right? I'm just going to write it. The length, area equals length times width. So area equals length, 10x plus 10, times the width. What's my width? 4x plus 20. Okay? So now I need to multiply length times width. Two binomials by each other. You think that's going to be similar to what we just did in the first two examples? Absolutely. I see two binomials, so I'm going to do my FOIL method. I'm going to multiply my first terms by each other. What's 10x times 4x? 40x squared. What's 10x times 20? 200x. What's 10 times 4x? We need to now multiply our inner terms. 40x. And what's 10 times 20? 200. Multiply the leading digits and add your zeros. But is this my final answer for area? Is everything combined that could be? No. What can I combine together? Okay. Not 200 and 200, but 240. Okay, so 40x squared, bring it down, plus 240x plus 200. And then we say feet squared. You say, well, Ms. Kinder, that didn't really tell me a whole lot, right? That doesn't really tell me how many square feet. Here's why. You don't know what x equals. You don't know what it equals. So if you don't know what it equals, how can you actually find the true area? Which is what the second problem now is going to help us do. It says, find the area of the football field when the width is 160 feet. So what if, instead of 4x plus 20, what if I had 160? Okay? So what I'm saying here, and guys, you have to be taught this process. You probably still right now have no idea how that could help you solve this. I have to teach it to you, but here's what I expect. The next time I give you a problem like this, you know how to get past step one, okay? So if the width is 160 feet, then it is true that 4x plus 20 equals 160, okay? So look here. It said that the width was 160 feet, correct? That means that 4x plus 20 right here, whatever that combination is, will also equal 160. So you can set them equal to each other. All right? Now we can solve for x. If the width is in fact a total of 160 feet, then this combination will also be 160. So now solve for x. It's going to be a simple two-step equation here. We've been doing these since day one of pre-algebra. I need you to solve for x here. Okay? So this part is not a new concept. What is step one to solve for x? Y'all tell me. Just tell me. Subtract 20. Subtract 20 to the other side. And you get 4x equals 140. Now, how do you solve for x? Divide both sides by 4. And x equals 35. Okay? So how does this help me? How does this help me? Well, if I know my width is 160, could I use my value for x now to figure out what my length is going to be? It's the same value. So now plug in 35 into your length expression to figure out what the actual length is. Go ahead and plug in 35. And again, I have to show you guys the first time how to do this. All right, so if you're thinking, man, there's no way I could have figured this out by myself, that's okay. All right, just next time we look at a problem like this, we need to have a better idea. All right, does anybody have a value for length yet? What is 10 times 35? 350. What's 350 plus 10? 360. So now I have an exact length and an exact width. How do I find area? How do I find area? What's the area of a rectangle? Length times width. So what am I going to do with those two numbers? Multiply them together. A equals length times width. So A equals 360 times 160. And A equals 57,600 square feet. Or feet squared, however you want to say it. All right. And if you understand that, that's everything you need to know for polynomials day 2.